Good evening, class. This is Nepson from Orlando Lakes campus. The subject I chose was image quality, and this is what we're going to be covering this mini lesson on. Image quality was my selection because it's a very broad subject that I have previously researched. A lot of the parts of image quality were intriguing to me, and also you have a lot of things that you're able to research on the subject and will not get stuck with a subject that does not have a lot of meat. All right. Image quality factors: contrast slash brightness, noise, scatter, spatial resolution slash recorded detail, and artifacts. The quality of medical image is determined by many factors. These are the main factors that I will be covering. Contrast slash brightness. The shades of gray displayed in an image is is a part of contrast. Increased number of shades of gray brings up the contrast. Contrast between different parts of the image is what forms the image greater. Contrast between different parts of the image is what forms the image, and the greater the contrast, the more visible features become. Absorption differences within the subject will affect the level of contrast in the radiograph. Radiographic contrast describes the differences in photographic density in the radiograph. Contrast continue. Low energy radiation is very easily attenuated. Generating X-rays using low kilovoltage will generally result in radiographs having too high contrast. This in turn will result in the film being exposed to a greater and lesser degree in two areas. Here are some examples of different levels of contrast. You have this right here. This showing the different levels of contrast. The middle one is where we would like it as far as visibility. You can see the structures well on this one, and the image represents the atomic structure. Noise. Quantum noise is not used for diagnostic information. Noise only serves as distraction from the quality of the image. The X-ray photons that hit the image receptor in a random pattern noise for no force can cause them to be evenly distributed over the surface. One area of the receptor surface might receive more photons than another area, even when both are exposed to the same X-ray intensity. Here are some examples of different levels of noise. When you have an image like this, you're not able to see what you're able to see, and it could have just been the wrong exposure factors, or they didn't use the grid. The patient may have been of bigger size, and you weren't able to see the detail that is needed to see. So pretty much the penetration was not enough. Imaging procedures using X-ray photons. Most of the image noise is produced by a random manner in which the photons are distributed within the image. Each individual photon is a specific quantity of energy. The quantum structure of the X-ray beam creates quantum noise. Noise is visible through the fluctuations of density on the image receptor. The more photons that reach the image receptor, the less noise there will be. Scatter can cause unwanted density to the radiograph. Scatter can occur on both soft and bone tissue. The higher the energy of the X-ray beam, the lower the amount of scatter that will be. Digital image receptors are more sensitive to scatter radiation than film since they pick up low levels of energy easier. Using a grid limits the scatter, which helps produce a better image. The grid limits the constant interaction, and more information reaches the image receptor. As you see, I have this example with a grid and this one without the grid. Spatial resolution, this is also known as recorded detail. Spatial resolution is the ability of a radiographic imaging system to record detailed images. In many cases, the digital image cannot accomplish the resolution of film images. Low spatial resolution techniques will be unable to differentiate between two objects that are relatively close together. The greater the number of pixels per unit are, the better the spatial resolution. Artifacts. Any undesired portion that is on the image that is covering atomic structure. Artifacts can block important parts of the anatomy. The presence of artifacts can cause an inaccurate diagnosis or can cause the film to be retaken. Best way to prevent artifacts is clear communication and instructions to the patient, and remove all possible artifacts from their person. Here are some examples of artifacts. This was just a chain. These look like some type of clips, maybe suspenders. These are just some tubes that the patient may have. In this situation, you may not be able to remove these tubes. You probably would have to ask the doctor or the nurse to remove those if need be. A quality radiographic image accurately represents the area of interest and provides the radiologist with the necessary information needed with diagnosis. Using the appropriate settings to minimize the patient exposure and re-exposures will go a long way in the patient's safety. Here are some references used for this presentation. Thank you for your time. Have a great day.